Hello everybody. Today in this video we are going to learn how we can use pycnometer for determining the specific gravity of soil solids. So this is pycnometer. Now this pycnometer is basically used in the laboratory for two purposes. The first purpose is to determine the specific gravity of the soil solids, whereas the second purpose is to determine the water content of the soil solids. Now first of all we shall look how we can calculate the specific gravity of soil solids using this pycnometer. So first of all we have this empty pycnometer. So we determine the empty weight of the pycnometer and we designate the weight as W1. So W1 is the empty weight of the pycnometer. Now we shall have a soil sample that is fully oven dried, for which the for which the specific gravity is to be determined. That is, we are trying to determine the specific gravity of this solid. So this soil solid should be completely oven dried so as to ensure that it is free of any moisture, surface moisture, as well as the adsorbed water must not contain in this sample. So this is completely dry, oven dried sample. So we shall put this soil into this pycnometer and measure the weight of this soil and the empty weight of the pycnometer and mark the weight as W2. So W2 is the weight of the empty weight of the pycnometer plus the weight of the dry soil. Okay, so W1 is the empty weight of the pycnometer. Empty weight of pycnometer. Now the third step is to fill the pycnometer with water up to its top level. So W3 is the weight that has the weight of the empty weight of the pycnometer plus the weight of the dried soil sample and the filled water. So this W3 is W2 plus weight of water that is filled. So I am going to write it as weight of the filled water. So this is W3. Now for determining W4, what we do here is remove all the stops from this pycnometer and fill the pycnometer by water up to its level top to determine W4. So W4 is basically the weight of the empty pycnometer W1 plus weight of filled water. So this is W4. Now what we do after determining these four values is we determine the specific gravity of the pycnometer, which can be determined as W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So this is how we determine the specific gravity of the soil solids using pycnometer. So we have looked this formula. Now let us look how this formula works. So as we know, the specific gravity of a soil solid, remember we are dealing with soil solids, there is the solid that has no voids within it and only has soil solids. So the specific gravity of soil solids is the ratio of the weight of soil solid to the weight of equal volume of water. Equal volume of water. This is the standard definition of the specific gravity of soil solid. Now let us look at this term W2 minus W1. So as we know, W2 is basically W1 plus weight of dry soil. So if we subtract W1 from W2, then what we are basically left with is, since this term get cancelled, we are left with weight of dry soil only. So W2 minus W1 is equal to weight of dry soil. So weight of dry soil here and weight of dry soil or weight of soil solid is the same thing here. And since W2 minus W1 originally contains the weight of the dry soil plus the weight of water, the weight of the air, and since we neglect the weight of the air, so what we are left here with is the weight of the dry soil, and this is also the weight of the dry soil, this upper term. So W2 minus W1 justifies this upper term. Now let us look at the below term. There is weight of equal volume of water. Now to determine this below term, let us look W3 minus W4 first. So W3 is the weight of the empty pycnometer plus the weight of the soil solid plus the weight of the water filled, weight of the completely filled water. This is W3, and W4 is the weight of the empty pycnometer plus the weight of the fully filled water without the soil sample. So let us consider this to be a pycnometer and consider this as well to be the weight of the pycnometer. Then W3 has the empty weight of the pycnometer plus the weight of these soil solids inside the pycnometer and the weight of the water inside the pycnometer. This is W3, whereas W4 is the weight of the empty pycnometer plus weight of the completely filled liquid inside the pycnometer. Now if we perform W3 minus W4, then let's see what we are left with. The empty weight of the pycnometer cancels in both cases and the resultant value would be 0 for the weight of the pycnometer, and the weight of the water, this water plus the water surrounding the voids, is also present in this W4. So all this water except for this volume occupied by the soil solids will get cancelled from W4 since every portion of it has water. Then what remains in W3 minus W4 is the weight of these soil solids and the weight of the same volume of these soil solids that is occupied by water. So these all volumes are occupied by water. So what we are eventually left with is weight of soil solids the weight is this solid's weight minus weight of equal volume of water. Since these all volume will be occupied by this volume, but this volume are occupied by water, so weight of equal volume of water is occupied by the soil solids in W3, right? So what we are left with is weight of soil solids minus weight of equal volume of water is occupied by soil solids in W3. So now if we perform W2 minus W1 minus W3 minus W4, then let's see what happens. W2 minus W1 is the weight of the soil solid, so I am going to write here like this: weight of soil solid minus what is W3 minus W4 is weight of soil solid, there is weight of soil solid minus weight of equal volume of water is occupied by soil solids. So weight of water which has equal volume is soil solids, right, is occupied in this W3. So this term and this term gets cancelled out, and we have weight of water that occupies equal volume is soil solids. And if we look at this term, then this is also weight of equal volume of water, and this is also weight of equal volume of water. So this W2 minus W1 minus W3 minus W4 term completely justifies or completely replaces this term. Hence the upper term is replaced by W2 minus W1, and the below term is replaced by W2 minus W1 minus W3 minus W4. In this way this formula works. So this determines the weight of the soil solids by volume of equal weight of equal volume of water for determining the specific gravity. Now similarly we can look at this Lee Chateliers specific gravity flask, which is used to determine the specific gravity of the cement particles. So we know the specific gravity of cement particle lies at 3.15, and the 1440 kg per meters cube is the bulk density of cement. Remember, this bulk density of cement is the density of cement with voids. A cement is considered to have 40% of voids, but this is the specific gravity of the cement without any voids. It contains only the cement particles without any voids and without any moisture. Now the process is similar to that of the pycnometer for determining the specific gravity of the cement. So W1 is the empty weight of this flask, W2 is the empty weight of the flask plus the weight of the cement. Now here comes W3. Now if we put water here, then cement reacts with water to form calcium silicate hydrate gel, which is a binder. So we cannot use water here. So what we need to put here is one of the materials that doesn't react with cement, and we use here kerosene as the material that doesn't react with cement. So you may be asked in interview as well, does kerosene react with water or not? Sorry, does kerosene react with cement or not? And the standard answer or your answer should be no, kerosene does not react with water. And you can give the reference of the Lee Chateliers specific gravity flask or this procedure to determine the specific gravity of the cement. So W3 is the weight of the flask, empty flask, plus weight of the dry cement, plus weight of the fully filled kerosene inside this flask. And W4 is obtained by removing all the stuffs from here and filling it with water. So the weight of empty Lee Chateliers bottle plus Lee Chateliers flask plus the weight of the water filled up to its top is W4. just like in the case of pycnometer. So by using the same formula, we can determine the weight of dry cement. That is weight of cement solids divided by weight of equal volume of kerosene, since this bottle is filled up by kerosene. So this gives W2 minus W1 divided by W2 minus W1 minus W3 minus W4. But here we are interested in calculating the specific gravity of cement, which is the weight of the dry cement by weight of equal volume of water. Weight of equal volume of water, but this term has weight of equal volume of kerosene, so we can use 0.79 value, since this value is the weight of kerosene by weight of equal volume of water, since 0.79 is the specific gravity of the kerosene. So if we use this here, then we obtain weight of dry cement by weight of kerosene, and this 0.79 will come as 1 over 0.79. So if we replace this formula, this weight of dry cement by weight of equal volume of kerosene in here, then we get W2 minus W1 into 0.79 divided by W2 minus W1 minus W3 minus W4. So in this way we can determine the specific gravity of cement as well. Thank you. This much for today.